Hi class, my name is Mushere Nyaga. I'll be taking you through the introduction to mobile application development. And today we want to start with the main objective of this lecture, or the main objective of this lecture is to have the introduction to a brief history of mobile, and then we have the mobile ecosystem and why have we decided to focus on the mobile. And then we will discuss about type of the mobile applications that we have, the mobile information architecture, the mobile design, the mobile web development, and small computing devices requirements. And lastly, we are going to start with the introduction to Java, or the overview about Java as a language and as a program. So, mobile have changed the way we live, the way we do businesses, and a brief history about mobile phones is that the first mobile phone was used for emergency services and to connect the taxi drivers and the emergency services. That was in the US. But in 1973, to be very specific, on 3rd April, Motorola company made it commercial for mobile phone so that ordinary people can be would be in a position to purchase the mobile phone. So in 1973, ordinary or civilians were able to access phone. That's a sample of the Motorola 8000X, and that was the founder of the mobile. You can look at the size of the first computer, and that was, and compared to today, you would see a lot of improvement. So the pre-standardization of mobile has taken so many years, starting in 1947, where AT&T was the first company in the world to have a mobile telecommunication network. That is equivalent to the Safaricom. So in 1947, an American company was in a position to introduce a telecommunication company, which was commercial. Remember, when you talk about commercial, that means ordinary citizen would be in a position to access the mobile services. Previously, we would say the military used to use the walkie-talkies, but for that, we won't be discussing that. So, in 1947, the AT&T used the mobile telephone service, or the commonly abbreviated as MTS. These used an operator, that's a physical person who used to be in an operating room connecting the caller and the receiver of the phone. So you had to call first the operator of the call, and he or she connects you with the other person. So both the incoming call, the outgoing call had to pass by through a third party. And that wasn't, it wasn't much, it was less effective, and that introduced the 1G, or the first generation cellular networks, right? That was in 1977 in Chicago. The 1G network paved the way where the incoming call would be interswitched through towers, and you'd go, or you'd call via towns without the need of an operator. So the introduction of cell towers improved the communication, and that the researchers went ahead and introduced the second generation mobile phones. So the 2G was introduced was introduced after the 1G network, and that brought an aspect of SMS sending, with the first computer-generated SMS being generated in 1992 in the UK. All right. In the 2G network, also the element of the download technology or access of resources via downloading was introduced. Right. And the first thing that was introduced in the 2G network was a ringtone. Those people who are there during 92, you just download a ringtone, and that was the first technology to be enabled. So, and that brought about the 3G network. The 3G network transformed the mobile phone industry and enabled mobile internet and the transmission services like the TV, the radio, and also the internet and the download speeds improved. And that brought about the smartphone. And that was the start of smartphones. So the 4G network is the current technology that's in 2020. Essentially, it is an improvement of the 3G network, addressing two major issues. That was the speed and network congestion. In the 3G network, we had a bit of slower speed, but now the 4G network improved the speed and the network congestion. So, and that's where we are. Now, the future network, or the next network that most countries and most users are targeting is the 4G network, or 5G, sorry. The 5G network is a network that has introduced the Internet of Things and the artificial intelligence in the IT world. It's addressing the speed, technology, the low application, the services, and also you can be in a position to check on business opportunity via the internet. So why mobile? Mobile phone are giving us freedom. Freedom in terms of you can communicate anywhere, anytime, any place. So this is a technology that is worth pursuing. So what is this wireless communication? Because we don't leave a room of assumption. What is the wireless communication? Wireless communication is the transfer of information over distance without the use of electrical conductors or wires, right? You might ask me why I've decided to use the word distance. Sometimes most students ask about what is talking part of wireless communication. Yes, it's part of it, but in terms of technology, we are talking about people who are separated physically. So how do you achieve wireless communication? How do you achieve wireless communication? You can use radio frequencies, you can use microwave, that's the long range and the line of sight via antennas communication. You can use the global system for mobile computation, which is commonly called GCM. And then you can use the general packet radio system, which is the GPRS. And also you can use the 3G, the global positioning system, which is the GPS. That's where you achieve wireless communication. We have other ways, which is the 4G, which is the most current, though that's another way you can achieve wireless communication. So let's discuss slightly about GCM phone before proceeding to the mobile development, because before we start with mobile development, we have to start somewhere, which is the the GCM, which is the Global System for Mobile Communication. The GCM is the global standard for digital cellular communication. The GSM uses a time division multiple access, TDMA, right? That's for the voice and the short message services, commonly called the SMSs. The GCM digitizes and compresses data, then sends it down to other streams using a frequency band, right? It has 5 different cell sizes. We have the macro, we have the micro, the pico, the femto, and the umbrella cells. While we're discussing about the GCM, we will be going in detail about these different sizes of cells. So we can proceed on. We can talk about the GCM architecture. How or what are the things involved in the GCM architecture? The GCM architecture consists of several functionalities entities. That is the mobile station, the base station, the substation, the networking switching system, and the operation support system. Remember, these are just the main things. We have other subsystems that are available in the architecture. This is the pictorial view of the architecture. You can see we have the PSDN, we have the ISDN, PSTN, PLMN, and the OSS you can see. You can see we have different interfaces. We have the A interface, we have the UM interface, right? So we can proceed and we can go straight up to the GCM network. So this is a sample of representation of how a GCM network is represented. Remember, I understand we still have its mobile development, but before going to developing any application or discussing about any software, we have to understand the architecture underlying any network. So you can see we have the GCM network, we have the MEC, we have the BTS, we have the BTS, you can see the mast, we have the mobile. All these will be discussed in detail in the network classes. So we won't focus much on that. So we go next to mobile application development. Why mobile application development, right? Mobile application development is a set process where we develop software for small devices. Remember, a software is simply a set of instructions. But now in mobile application, we are focusing on small devices or small computers, right? It is a slightly different because of the sizes, and these are new technology that's currently focusing on small devices. So we have to check on different types of mobile application. The first one is called the native application. The native apps, as the name suggests, is built on a specific operating system. Like an example, when you talk about a native application, the OSI or the iOS operating system won't work on an Android service, right? And the vice versa. So if an application was developed for an OS system, it will remain exclusive. It will remain exclusive to the operating system. Like an example, a Swift for the the iOS, Java for the Android, and the C# for Windows operating system. So the next type of an application, mobile application, we have the mobile web app. The web application render and deliver packages on web browsers. Web browsers cut across different mobile phones and different operating system. So when you talk about maybe you're working on iOS, that's for the Mac or the Macintosh. The mobile web app can be used in both the Android and the Mac or the iOS, right? So these applications are used to get information or to display information via web browsers. So some of the software that are used to develop the application are general softwares that are HTML, CSS, JavaScript, jQuery, and so many others. So this one cut across. For the hybrid, the third one, the hybrid applications. For the hybrid application, these are a mixture of both the native and the mobile web apps. This is a type of application which has a cross-platform compatibility, right? When you talk about cross-platform compatibility, you can access in either any operating system, right? And any phone hardware. So it is not limited to any operating system. So it's a combination between the mobile and the native software. So an example, we have the HTML, CSS, JavaScript, jQuery, JavaScript framework, and the latest one from Google. I think in January. It was launched in January 2020. Is the Dart, which is a bit friendly and very exclusive. But let me take you back to the native application. The native application, like an example, the Swift, in case you want to be a developer, you can either focus on the Swift, depending on the users. Things to consider are the users. In case you want to focus on Java as a developer, you have to know who are the users of your application. Mostly, the most popular one is the Android application, and that's what you'll be focusing on. But before proceeding, we want to see some of the architecture of these, architecture of the mobile, or how do you place content in a mobile. First, or the first point to consider, you have to put the content first and creating the clarity of the purpose once a user tells you about an application. Secondly, you have to separate the taxonomy and the navigation. Remember, the taxonomy and the navigation. How do you go about accessing the information? Remember, any architecture, when you're developing any architecture, you have to put your thought to the user. How will the user navigate? So design taxonomies, categories, and classification schemes to make the organization of the content intelligible to users. In most cases, what we say is information that is making sense. Sometimes you can access a mobile application that is that information is not well arranged. So making it making the users hard to use. So Another thing to consider is the design navigation. When you talk about navigation, it's how or the human, and we will bring the concept of human-computer interaction, the design, the navigation, and the interaction to make the content appropriate. You can have good content, but when the navigation is a bit difficult, it will be a bit of a challenge. So in the architecture, navigation is very, very key to any user. So learn the patterns and the guard against falling into default patterns. Don't make your application too obvious. So you have to guard against falling into default patterns. So the last three, build a future-friendly and reusable foundation. When you talk about future-friendly, it's the aspect of once you decide to scale up your mobile application or to improve your mobile application, let the user not find any or too much change on the upgrade. So in case it's the navigation and we have the home button, in case you decide to upgrade your mobile application, let there not be too much difference. So let your application be future friendly and reusable foundation. Foundation is very, very key for any architecture that you're working on. So the mobile design, any design or the presentation of a mobile app is very, very, very important. Remember that when you discuss about the mobile app, the first thing that comes in your mind is the small screen decisions. The small screen decision. That's why you have to consider the design. We have two major things that you work with. We have the first design, which is called the responsive design, where the devices handle the changes on display, right? So when you're making the design, you can decide that your application will be responsive so that the device handles the changes on display. When a user displays the mobile on a specific mobile phone, it will respond to the environment. So another thing, another design that is very important or very key that you need to consider is the adaptive design. The adaptive design is where your servers handle the changes. Adaptive, it's where the server handles the changes and the user of the application must select the option. And these two things, I won't tell you which is the most ideal, but as we move on, different mobile design or mobile application development design will be guided on either of these. A good process to follow would be group the devices that you're targeting to be using your application. So group the devices types based on their sizes. The second thing to consider is define the content, the rules, and the design adaptation and the rules, right? And then lastly, you have to adhere to the web standards commonly referred to as WD3. And in most cases, I put in these an NB. Something to note is that while you're considering all these, use flexible designs. When you talk about flexible designs, always consider the user. We always say, always consider the user. In case it's an entertainment application, I would decide that you're going to select on the best design, the color of your mobile application. All those are some of the things to consider. Let's continue. Keep navigation very, very simple. Any mobile application, the key thing or the key success is keep the navigation as simple as possible. So these are some of the steps to keep the navigation simple. Make it a priority, the navigation functionality. While you're developing, navigation should be a priority. How do you move from one page or one link to the other? Minimize the levels of navigation involved, right? Like an example, what I mean by minimize the levels of navigation involved. Sometimes you might decide to move, you're in the same application, but you want to move to another page. Don't make it so impossible for the user to navigate from one page to another. Make it as easy as possible. The third one, you have to ensure the labels are very clear and consistent. In case it's a home page, and the information, make sure the information that is available on the home page, it's very clear and consistent. When you go to about, maybe an about page, when you click on the about page, it should not link you again to the home page. So consistency is very key, and that is a good way. I'll just mention an example of a very popular application, which is the Google application. The Google application, it's very easy. You just need to click on the application, and it will just pop up the option of search. It won't start giving you the option of maybe translation. It will just give you the option, and the option will now link you to the translation pages and all that. The last option, make it easy to swap between mobile and full sites. Remember, mobile is the mobile application is a representation of the full site. So in case a user decides to go to the main site, make it easier for them to change from the mobile to the full site. Okay, so let's proceed on mobile web development. There are two main things that you need to know when you decide to be a mobile developer. These two words, the emulator and simulator, will be used in your day-to-day developing life. So what is an emulator? It is a piece of software that translates compiled code from an original architecture to the platform it is running, right? An emulator is a desktop application that emulates the mobile device hardware. So it imitates how it's remember, it's a desktop. Rather, let me put it, when you talk about desktop, let me put it a bit loose. A desktop computer. It will just, an emulator is used on the desktop application that emulates the mobile devices, right? And it shows how the application will be working on the daily life. So an emulator is a word that you'll be finding it, and you'll find different kind of emulators. The next thing is the simulator. A simulator is less complex application that stimulates some of the behavior of a device, but does not emulate hardware and does not work with the manufacturer or by some other user. Let me just explain a simulator. It simulates how your mobile application will be working. So it will be simulating a real life experience on a mobile work. So before you launch your mobile application, you have to put it on a simulator and it will show you how it will be working. Some of the examples that, or in most cases, some typical desktop application, we can talk about a web browser. An example, we have Chrome and Firefox, Safari. We have the Onion for the tool for those guys who have security issues, and that's an example of a simulator. We have different skin depending on the engine you are on. But as we move on, you will have an experience of a simulator. Let's move on to some of the requirement of the small computing devices requirement. There are minimum resources that are required for you to start developing an application. Like an example, I've decided to just put an example of Java micro application. What are some of the requirements? The devices that you're working on must have a minimum of 96 to 94 pixel display, that bitmap graphics, and have a way of users to input information such as keyboard or keypad or a touch screen. All these is just an input device. And then we have the second one. We have to have 128 kilobytes of non-volatile memory for you to be in a position to run the mobile information device. So another requirement, I think you have to have that 2 KB volatile memory must be available. So for those guys who can't remember, we discussed about the volatile memory and non-volatile memory. One requires electricity to be there, the other one doesn't require. It stores data permanently. So you have to have 128 kilobytes for non-volatile and 32 KB for volatile memory. A very important requirement, the device that you're working on must provide a two-way network connectivity. That means you have to be in a position to communicate with the two devices. The other, or the last thing, key things, this is just a highlight. We have so many other requirements. The native operating system must implement an exemption handling, process interrupts, be able to run the Java virtual machine. The JVM means it's called the Java virtual machine, and provide a schedule capability. So remember the native operating system. When you talk about native operating system, you're talking about the Android, the iOS, and in case iOS and the Swift, those are the working environment. For Android, it's Java. So those are some of the basic requirements of a device to run. So let's discuss about the Java overview. Java, people will ask you, is Java a language, a programming language, or it's a platform? It's a very simple answer. Java is both a programming language and a platform. It gives you an opportunity to develop mobile application, and it's a high-level, object-oriented, you can underline, object-oriented language. And it has a particular syntax and style of how it is executed. So a Java platform has a particular environment in which Java programming has to work or has to run. So there are 4 platforms which are the current. By The year 2010, there were only 2, but by 2020, we have 4. We have Java Platform Standard Edition, Java SE, we have Java Enterprise Edition, Java E, and we have the Java Platform Micro Edition, and we have lastly Java FX, mostly for graphics, but we're going to discuss on the next slide. But before we continue, we have to discuss about all Java platforms. The 4 platforms. All Java platforms must have a Java virtual machine. Has to have a Java virtual machine and an application programming interface. So when you're talking about any Java platform, either the Java Micro, the Java FX, you have to have the Java virtual machine and the application programming interface. So let's discuss about this Java virtual machine. This is a program for a particular hardware in the software platform that runs Java technology application. So you have to have Java, virtual machine for you to run any virtual Java technology. The other thing is an API, is a collection of software components that you can use to create other software components or application. Take note, whenever you see API, that's a bit how I try to understand these two, or to differentiate these two platforms. You have to know that the API gives you a room for the mobile environment. When you see anything with the API, just take note, there is a linkage between the mobile and the real Java environment. Let's discuss the Java editions and how they're used. We can start with the first one, which is Java ME, which is Java Micro Edition. Mostly the pros or the gurus who have used Java Edition, you will wonder why they use Java ME. It's Java Micro Edition. So it provides an API and a small footprint virtual machine for running Java programming language application on small devices like mobile phones. So as earlier indicated, API, anytime you mention APIs, what comes in your mind should be a mobile phone. So the API is a subset of the Java SE API alongside with a special class of libraries and small devices applications. So Java ME are often clients of the Java enterprise platforms. So the next one that you're going to go is Java FX. Is a platform for creating rich internet application using lightweight user interface APIs. So Java FX, whenever you see it, just remember we are talking about the graphics and how information will be viewed by the user. So that's on a very brief, but you're going to go in detail. Once you start understanding different platforms, you'll be in a position to understand, you will start appreciating different editions of this. The other edition, we have the Java Standard Edition, which provides the core functionality of the Java programming language. It defines everything from the basic types, the object of the Java programming, to the high-level classes used in networking, security, database access, graphical user interface, and the XML developing. So Java's Standard Edition is very basic, and you must know it so that you're able to navigate through the Java environment. The other one is Java Enterprise Edition. The Java Enterprise Edition is built on the, or it provides the API runtime. We'll be discussing about the runtime before the end of this class for developing and managing large-scale Sometimes you want to run so many applications on so many users. This is the environment. This is the environment that you use. An example: when you're working with a big organization and you want to test how scalable an application is, this is the platform to use. So those are the four platforms. But before we proceed, we need to check ideally about the Java Micro Edition, which is my favorite. The architecture the architecture rather. These are the modular design for J2Me. It enables an application to be scaled based on the constraint of the computing device. Depending on how small your device is, Java, allow me to use Micro Edition, is able to scale it down depending on the size of the machine. The other point is Java Micro consists of layers located above the native operating system that is used to connect, and it's called Connected Limited Device Configuration, SLDC. So between the Android application and the Java application, we have this layer. I don't know, we can lightly use it. It's more like the middleware between the native operating system and the platform itself. You will find the Connected Limited Device Configuration, which is installed in system to help in the runtime environment for small computing devices. So the work of the SLDC is to help in the runtime environment. So let's go and discuss about the three layers you'll find there. We have the first layer, which is called the configuration layer. That includes the Java virtual machine, which directly interacts with the native operating system. Remember, whenever you talk about native, and you're talking about Java, just replace that with Android operating system. That will make you easily understand what you're talking about. The configuration handles the interaction between the profile and the Java virtual machine. So that's the work of the configuration layer. The second layer is the profile layer, which consists of the minimum set of application programming interfaces called the APIs for small computing devices. And then we have the third layer, which is the mobile information device profile, which contains the Java APIs for user network connection and persistent storage and user interface. So something to remember on the basic requirements: you have to have network connections, persistent storage. You remember when you were talking about the volatile and non-volatile memory, and the user interface. Whenever you hear about the user interface, something or the topic that or the unit that should come in your mind should be human-computer interaction, because the recipient of our units are humans. So that should take you there. And then we can just highlight a little bit about the runtime environment. And this will be a very key thing in your life as a Java developer. The Java runtime environment is a set of minimum components necessary to create and run a Java application, and is part of the Java development, JDK. Remember, JDK is similar to the software development kit. This is the environment that you'll be living in as a developer. And this kit has the Java virtual machine, Java class libraries, and Java class loader. But for the first class, just digest that, understand about the history of Java, and then in the next class, we will be discussing about the Java virtual machine, Java class libraries, and Java class, and we will be developing the first program of Java. Thank you, and see you in the next class.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.